In this problem, the neon sign at Chuy's, which we know is my favorite restaurant, is made of glass tubing with an internal volume of 24.75 centimeters cubed. If the gas within this sign is at a pressure of 1.78 torr at 35 degrees Celsius, it's a warm day here in Florida, how many grams of neon are used to fill the sign? So this has to do with gas. And so let's start to think about what kind of a question are we using? So likely this will be a PV equals nRT. And if we weren't quite sure, we could start by listing out all of the things that we know and seeing what we're looking for. So we have a pressure of 1.78 torr. We have a volume of 24.75 cubic centimeters. And we also have a temperature, which is 35 degrees Celsius. So, and we are looking for how many grams. So N equals question mark, but we want this to be in grams. So we have PV and T, we're looking for N, and we can use R. So one thing is that there are different R values, but a couple of things to note. This needs to be in Kelvin, so we're gonna add 273.15, which gives us 308.15 Kelvin. The R value that I am going to use today is 62.36 liters times torr times moles is Kelvin. So we can use this Kelvin, this torr, but this needs to go into liters. Now, there are other R values. You could have easily used any one of those and made different conversions in order to solve this question. You should always get the same grams. So if we want to convert cubic centimeters to liters, it turns out that 1 cubic centimeter is equal to 1 milliliter, and there are 1,000 mils in 1 liter, and so our volume is 0.02475 liters. So now we can rearrange our PV equals nRT equation to where N equals PV over RT and start filling in the values. So we have our 1.78 torr times 0.02475 liters divided by our selected R value of 62.36 liters torr mole Kelvin. It's always a good idea to write out your units just to make sure that everything cancels. Now we need to add our temperature, which is 308.15 Kelvin. Oops. So when we plug all of this into our calculator, we have 1.78 times 0.02475. We're going to divide that using our parentheses by 62.36 times 308.15. When we do that, we get a very small value. So we got 2.293 times 10 to the 1, 2, 3, 4, 5, 6 to the negative 6 moles of neon. Now if we go back to our question, we want to make sure we're actually answering the real question, how many grams? So we're currently in moles, so we're going to use the molecular weight. So in one, we're going to rewrite this, 2.293 times 10 to the negative 6 moles of neon times in 1 mole of neon. We look at our handy dandy periodic table, there are 20.18 grams. So when we multiply those two values together, we get, again, a very small number. So we get 4.626 times 10 to the 1, 2, 3, 4, 5 to the negative 5th grams. But we should double check our sig figs. So up here, temperature has 2, pressure and volume have 3 and 4 respectively. So we only get 2, so 4.6 times 10 to the negative 5 grams of neon are within this sign.